Hello there! So today I'm making a video to showcase a little something that I made, but I also want to explain it, so that's exactly what I'm gonna do. What this invention is basically based on a video game character, or rather the ability of a video game character. If you've ever played the game Valorant, you would know there is a character named Cypher, which I like to play. So basically, as I quit that game, I decided to make his ability in real life. I made it out of a bunch of electronics that I just found laying around in my room. But it's okay, if you don't play Valorant, then it's literally just a sensor, you know? You walk in between it and signal interrupts and you get a notification that something is in the sensor. And here it is. So this is basically the sensor that I have built. It's, as you can see from the front, it's made out of a phone box, duct tape, these two circles, I'll get to that later, and this little light over here, and also this power cord hanging around. The power cord's actually inside of the box, but I just shoved it in there because it looks neater when I hold it like this. So let me explain to you all the parts inside of this. Alright, so as you can see here, I got the sensor over here already. I just have to open it, which is going to be fairly easy because it's just a phone box. There we go. So as you can see here at the moment, it's kind of a mess because of this, actually just only because of this power cord right here. If I could just take this out, it would be nice. Alright, so I got the power cord untangled, and I think everyone knows what a power cord is. Literally just supplies power to whatever it's connected to. But now over here, if I just put it that way, so let's see what components that we have. So there's an Arduino right here, okay, and under the Arduino is a Raspberry Pi, and they're both connected to each other from this little cable over here, this printer cable, because that's the interface of the Arduino. One thing to know about this is that as these two are plugged in, the Arduino and the Raspberry Pi, connected to each other, they're actually using serial communication to communicate with each other, to send signals to each other from this wire. This Arduino right here has pins attached to it that's connected to an ultrasonic sensor and an LED light. The LED light is mostly for debugging, but I just put it on the box because it makes it look cooler. And this microsonic sensor is what actually does all the hard work right over here. These two little circles on the outside of the box that are poking out, actually what they do is they send a frequency waves from one end, and it bounces back and receives it through the other end, and with complicated math you can find out the distance between them. These pins basically just connect to the Arduino, which the Arduino has some specially written code on it that makes it so that it does the complicated math and figures out the distance that the ultrasonic sensor is reading. And the Raspberry Pi down here is actually hosting a server. So this Raspberry Pi also over here has a little, you can't really see it that good. It's a little Wi-Fi adapter. So it's actually connecting to the internet and running a server. So when a client connects to this server, it's actually going to be receiving signals from the Arduino right here. It will receive those signals, and basically the Raspberry Pi will tell it that if, hey, there's so the sensors being activated, it will send signals from this server and to the client that's going to be running on my PC. And it also uses a calibration system that I have coded inside the client. So basically, when the sensor is just staying here, let's say it's over here and it's connected, when the client actually presses the button calibrate, it will calibrate the length, so it will get the length that it is right now, and if any interruption comes through this this length, then it will activate. Then also the LED will start flashing red. Alright, now that all the explanation is done, time to actually show this off. Alright, so here's the sensor all hooked up and everything. It's plugged to a power cord, and we're gonna test it out right now. So if I just walk over to my laptop and double click the application right here, you will see that it opens up a window. And if I press calibrate, and if I walk into it, it starts activating. And you can also deactivate it right here. Click that, and bam. That's how it works. So as you can see, it worked flawlessly over there at the example I just showed. But that's not actually the original. The code was written in C++. This was written in Java. However, right now my operating system, for some reason, is not loading up GLFW, the Windows handler, I suppose. What do you gotta do, you know? Sometimes code doesn't work. Anyways, let me show you the code that I wrote. Alright, so now I am on my computer and we are going to I'm gonna show you guys the code that I wrote. So let's just open a terminal and we will clone the repository. I'll keep the link in the repository in the description below. So click on that if you are actually interested. But we just press git clone and then copy it. There we go. Now we can see change directory into it, and this is the tripwire. We're actually going to open up in VS Code, so just give me a minute to do that. Alright, so I got the code opened up here in VS Code. So we'll look at the client in GUI. This is written in C++, but the old one was written in Java. I'm going to show you this one because this one is actually the first build that I've made. So we're not going to go into the GUI stuff because that's kind of boring, but we're going to go into the networking. So this basically just connects to the Raspberry Pi, the one that's hosting the server. And it's basically just sending signals of calibration, and when you close the window, it will send a message to restart the Raspberry Pi calibration. Now we're going to go to the Pi server. So basically right here, this is all the code to run a server, and over here, this void message function, it will loop infinitely and send and receive messages. Actually, it will only receive messages over here, so it just keeps listening, and it will receive a message anytime the client sends. Now this over here, void function get Arduino car, is basically just for the serial communication between the Arduino and the Raspberry Pi. So I'll show you the Arduino code in a bit, but when it sends a signal to the Raspberry Pi, the Arduino, it will basically send the message for the calibration. So over here is all the Arduino code. It keeps looping, of course, that's the main function. But if the serial reads the code 99, so basically the letter C, it will calibrate. And the calibration is actually fairly simple. You just create a variable and you make it equal to the current distance that the ultrasonic sensor is sensing at the moment. There's the exit case, which will make the calibrated length just 0. So basically it will restart everything for a new client to join. Here, if the Arduino detects an interruption between the calibrated length and the distance, +5, so we don't have a interruption problem, because sometimes the ultrasonic sensor cannot really make it, an exact number. So if it does detect interruption, it will write to the Raspberry Pi which will basically send the Raspberry Pi will send that signal towards the client, and the client will start flashing. So basically the interruption code. So that's basically all the code that there really is to it. It's not much, but it still is fairly complicated. There's a lot of do with the Arduino's serial connections and server manipulation, and sending bytes of data to the client. But anyways, that's going to be the end of this video. Stay tuned for more, because I really enjoyed making this. Give a fat thumbs up and subscribe to the channel if you want. And that's been me. See ya.